Assumed mean deviation method. Find the Carl-Pearson coefficient of correlation between x and y from the following data. So draw the tabular column and first you write down the serial numbers. You have 7 values given. Then first you write down all the x values, capital X. Then write down all the y values in the third column. Then here we take assumed mean. We don't take actual mean. Instead we take the assumed mean. So for x values we take 16 as the assumed mean. So subtract 16 from all the x values. In the fourth column, x minus a, that is x minus assumed mean, gives you dx, small d, small x. 10 minus 16 gives you minus 6. 12 minus 16 gives you minus 4. 13 minus 16 gives you minus 3. 16 minus 16 gives you 0. 17 minus 16 gives you 1. 20 minus 16 gives you 4 and 25 minus 16 gives you 9. In the same way, take assumed mean for y also. So the center value is fourth value, that is 27. Subtract 27 from all the y values. 19 minus 27 minus 8. 22 minus 27 minus 5. 26 minus 27 minus 1. 27 minus 27 0. 29 minus 27 2. 33 minus 27 6 and 37 minus 27 gives you 10, and that is dy. And always you give the total also. So n is 7 here, sigma x, that is total of all x value, capital X, remember, is 113. Then sigma y, that is capital Y, sum is 193. Then dx, that is total is 1. And it is also called as sigma x minus a, that is x minus assumed mean, or even you can write it as dx. Then y minus a is equal to dy and the total is 4. So when you have both positive and negative integers, add the positive integers separately, negative integers separately, and subtract and give the sign of the greater number. Then you have to square the dx values. So in the sixth column, you write down the squares of dx. So minus 6 square is 36, minus 4 square is 16, minus 3 square is 9, 0 square 0, 1 square 1, 4 square 16 and 9 square 81. Then you give the dx square. Then in the next column give the dy square. So in the seventh column give the dy square. Minus 8 square is 64, minus 5 square is 25. Minus 1 square is 1, 0 square 0, 2 square 4 and 6 square 36 and 10 square 100. Then multiply dx values with dy, not square values, dx value with dy, that is after subtracting the assumed mean values. So dx dy is multiplying dx values with the dy values. So first one, minus 6 into minus 8 gives you 48. Minus 4 into minus 5 gives you 20. Minus 3 into minus 1 is equal to 3. Then 0 into 0, 0. 1 into 2, 2. 4 into 6, 24. And 9 into 10 is equal to 90. Then add all the dx dy. It gives you 187. So sigma dx dy is equal to 187. Now substituting in the formula. So x bar is equal to, here though it is assumed mean method, they have taken the actual mean also, that is sigma x divided by n, 113 divided by 7 is equal to 16 1 by 7. So the assumed mean they have taken it as 16, and for y it is 193 by 7 is equal to 27 4 by 7, and the assumed mean taken was 27. Now substituting the values, so r is equal to n sigma dxy. So number of values is 7 here, and dx dy total is 187. So 7 into 187 minus sigma dx into sigma dy. So sigma dx total is, that is dx total is 1 and dy total is 4. So 1 into 4. And always remember the board mass rule. First you should multiply, then only you should subtract. Whole thing divided by root of n sigma dx square. So 7, number of values is 7, and the sigma dx square. So dx square total is 157. So we substitute it there, minus sigma dx the whole square. So when it is dx the whole square, dx total is 1, and that you have to square, into root of 7 into 230. n is 7 there and sigma dy square is 230. That is the total of d square is 230 minus sigma dy the whole square. So dy total is 4, so 4 square. On calculating the values, 7 into 187 is 139 minus 1 into 4 is 4 divided by root of 7 into 159 minus 1 square gives you 112 into root of 7 into 230 gives you 1610 subtracted by 4 square is 16. On solving it further, 1305 divided by root 112 into root 1594. So you can take separate roots also. So root of 112 is 33.34 and the root of 1594 is 39.92, and multiplying both the values it gives you 1330.9, and the numerator remains the same, 1305. On dividing the numerator 1305 by 1330.9, it gives you 0.9865, and rounding it to the 3 decimal numbers it gives you r is equal to 0.986. And in this problem also the solution is a positive high correlation because the answer is in positive. So there is a positive correlation between x and y.